Let's begin Chapter 3, Section 3. After you have read these objectives, you can go ahead and start number 1. Solve the linear programming problem. Maximize z equals 40x plus 12y subject to these following constraints. So the first step to do is let's make a table and let's substitute x equals 0, and then we will substitute y equals 0. So when x is equal to 0, you have 12 divided by -2, which is -6. And then when y is equal to 0, you have 12 divided by 6, which is 2. And there we have 0, -6, which is somewhere down there. And then you have 2, 0, and that's that line. Now the second inequality, we do the same thing. Let's substitute 0 into the x. And then we have y is equal to 9. And then we substitute 0 into the y. And then you have 9 divided by 3, which is 3. So here you have 0, 9, and 3, 0 is there. Now to shade, let's plug in our test point, and we can plug in 0 and 0. So 0 is less than or equal to 12, which is true. So we shade towards the 0, 0. And then the other inequality, we plug in 0 for x and 0 for y. And we have 0 is less than or equal to 9, which is also true. So then we shade toward the 0, 0. So this is our feasible region, and it is bounded by these 4 corner points. So the 4 corner points, the first one is 0, 9. And then we have this corner point, which is 2, 0. We have 0, 0. And then we have this point of intersection. And that point of intersection I solved by the elimination method. So the elimination method, which is also the addition method, tells you that you want to cancel one of the variables. So here I want to cancel the y. So to cancel the y, I want to multiply the second equation by 2. So I have 6x plus 2y is equal to 18. And let's combine that with the first equation. And here my y's cancel, so I have 6x plus 6x is 12x is equal to 30. Divide both sides by 12. I calculate x to be 2.5. And once I solved for x, I substitute that back into my equation and I solve for y. So I'm going to plug it back into the second equation. So I have 3 times 2.5 plus y is equal to 9. So 3 times 2.5 is 7.5 plus y is equal to 9. Subtract 7.5. So y is equal to 1.5. And this is my other corner point, 2.5, comma 1.5. So now I substitute each corner point into my objective function. And my objective function, again, is maximize z equals 40x plus 12y. So plugging this in here, I have 0 times 40 plus 12 times 9, and that is equal to 108. And then I have z is equal to 40 times 2 plus 12 times 0, and that is equal to 80. And then z is equal to 40 times 0 plus 12 times 0, and that is 0. And then z is equal to 40 times 2.5 plus 12 times 1.5, and that is equal to 118. And the maximum number is 118. Therefore, the function has a maximum value of 118 at point 2.5. Now let us continue with number 2. here, this problem, you want to minimize the following objective function. So minimize z equals 13x plus 12y subject to the following constraints. So let's first get rid of that fraction. So let's get rid of this 3/2 by multiplying all terms by that denominator of 2. So by doing that, we cancel the 2 and we're left with 3x minus 6y is greater than or equal to 12. Okay, now let's make our table and draw our line. So when x is equal to 0, you have y is equal to -2. And then when y is equal to 0, you have 12 divided by 3, which is 4. So your 0, -2 is down below, which you don't need. But here you have 4, 0, and there's the line. Plugging in your test point, 0 is greater than or equal to 6, which is not true. Therefore, you shade away from 0, 0. Let's do the same thing to the second inequality. So again, when x is 0, you have 14 divided by 2, which is 7. And then the same thing when y is 0, you have 14 divided by 2, which is 7. So you have 0, 7 is there, 7, 0 is here, and that's that line. And then plug in a test point. 0 is greater than or equal to 14, which is not true. Therefore, you shade away from this test point of 0, 0. So here we have our corner points. It's just 2 corner points. So the first one here is 7, 0. And then the other point of intersection we can solve by the elimination method. So we have 3x minus 6y is equal to 12. And 2x plus 2y is equal to 14. So I'm going to multiply my second equation by 3 so I can cancel my y variable. So I have 6x plus 6y is equal to 42. And 3x minus 6y is equal to 12. So my y cancels, and I'm left with 6x plus 3x, which is 9x. 42 plus 12 is 54. Divide by 9, we have x is equal to 6. And substituting 6 back into the original inequality. So let's substitute the x into the second equation. So 2x plus 2y is equal to 14. So 2 times 6 plus 2y is equal to 14. So I have 12. 14 minus 12 is 2 divided by 2. I have y is equal to 1. And this is my second point. My second corner point is 6, 1. So now let's substitute that into the objective function. So z is equal to 13 times 7 plus 12 times 0. And that is 91. And z is equal to 13 times 6 plus 12 times 1. And that is equal to 90. Therefore, the function has a minimum value of 90 at 0.61. And that completes Chapter 3, Section 3.